We're trying to do this problem that says a 30-foot ladder is leaning on the side of a barn while the base is pulled away from the barn at a constant rate of 1 foot per second. At what rate is the top of the ladder moving down the barn? And this is going to depend on how far the base is away from the barn. We're going to figure the rate when the base is 4 feet from the barn, when the base is 10 feet from the barn, and the base is 20 feet from the barn. Let's go ahead and draw a sketch. I'm going to draw green for the ground here. And then we'll draw a little barn. And then we have our ladder. We know the ladder is 30 feet long. Notice that from the base to the bottom of the ladder, probably that ladder might fall over. So let's do this. From the base to the bottom of the ladder is one distance. From the top of the ladder to that bottom of the barn is another distance. And then we know the ladder itself is a distance. So these three measurements make up a right triangle. We have a right triangle in here. And we know the hypotenuse of this right triangle is the 30-foot ladder. The base here we'll call B, the height we'll call A. And what we know about these three lengths, at least the relationship between these three lengths, is that A squared plus B squared equals C squared. That's the Pythagorean theorem. That's something you probably have seen before. That is the equation that we're going to use. A squared plus B squared equals C squared. Like I said, the hypotenuse is 30, so we can simply fill in the 30 because the ladder is always going to be 30 feet tall. At this point, we want to talk about rates of change. And essentially, we were given a rate of change of B, and we want to find the corresponding rate of change for A. I'm going to go 30 squared. I'm going to write that as 900 before I get any further. So I'm going to take a derivative of this equation with respect to some time. If I do that, I have to realize A is an inside function. So 2A multiplied times dA dt plus B is an inside function, 2B multiplied times dB over dt. And the derivative of 900 is 0. So that's what we get. If we want to make this a little more straightforward, 2A multiplied times dA dt is equal to negative 2B multiplied times dB dt. And we're going to be using that. So the first measurement is when the ladder is 4 feet away from the barn. or the ladder's base is 4 feet away. Okay? So the ladder's base being 4 feet away means I called the base B and then the height on the barn A, if you recall. So that means that this B becomes a 4. The problem also said that the ladder is moving away from the wall at a rate of 1 foot per second. We're almost done. The only thing I need to do is find A. If the base is 4 feet away from, or excuse me, if the ladder is 4 feet away, in other words, B is 4, how can I find A? What's A when that happens? Well, if I think back to this picture, 30 is the hypotenuse, 4 is the base. In order to find this A, I can simply calculate with the Pythagorean theorem and solve for A if I have the other two sides. So I go back to my Pythagorean theorem here. And when the base is 4 foot away, the ladder is still 30 feet long. The base is 4 feet away. I can solve this equation for A. 30 squared minus 4 squared becomes 884. That's A squared. So A squared is 884. Take a square root of 884 and you get about 29.73. I'm just going to call it the square root of 884 for sake of ease. That way, when I put it into my formula here, it looks a little bit nicer than having to write a bunch of decimals. Now I can solve for the rate of change of A. So as the ladder moves away at the base, the top of the ladder is moving at a rate of, well, take -2 times 4 times 1, and then divide by 2 times 8, square root of 884. So essentially -8 divided by 2 times the square root of 884. I got -0.1345. So as the ladder moves away from the base, the top only moves down at a rate of about 0.1345 feet per second. Remember, the ladder was moving away at a rate of 1 foot per second at the base, but it doesn't go down very much because the base is pretty close. We can look at what happens when the ladder gets further away as well. When the ladder base is 10 feet away from the barn, obviously. Well, we're going to have to go and do the same process. We're going to have to use this formula. But before I do that, let's go ahead and find where the A is at. So when the base is 10 feet away, A squared plus B squared equals 30 squared. The B here is 10 feet away. And if I solve this, 30 squared minus 10 squared is 800. And that doesn't have a nice square root. 800 is about 28.28. Or square root of 800 is about 28.28. So A is equal to, I'm going to call it the square root of 800. So there you go. Now we say we know our rates of change are related in this way. The base is 10 feet away from the barn. So we're going to put in, keep the formula, base of 10. We're moving away at a rate of 1 foot per second. The A here we just saw was square root of 800. And now we can solve dA with respect to t, the rate of change that the ladder is moving down the barn, is going to be negative 3.5355. Again, this negative is implying it's moving down along the barn, all right, not moving up. So as the base gets away, the top of the ladder is falling down. That's what that negative is symbolizing. And again, this is feet per second if we want. So notice when our base was pretty close to the barn, moving out that base a little bit didn't change the top a whole lot. But when our base was pretty far away from the barn, moving out a little bit mattered significantly. The next one is when the base is 20 feet from the barn. Because that's so similar, I'm just going to copy and paste my work from above and change the 10 to a 20. I find the distance along the barn, 30 squared minus 20 squared is a 500. So A squared is 500. A would be therefore the square root of 500. My B is 20. My rate of change is 1 foot per second. Square root of 500 is my A. And then I can go and solve. So negative 2 times 20 times 1 divided by 2 times square root of 500. Make sure that when you're writing this down, it makes sense and all of that. So derivative of A with respect to t, the rate of change on the barn is negative 0.8944. Again, that's feet per second. Notice that this is once again slower. And so that's kind of an interesting phenomenon, that in the middle is where the rate of change was the fastest. The rate of change is really slow when the ladder base is really close. And it's pretty slow when the ladder base is far away. But in the middle, it's a little bit faster. That should make sense because if it's at top, we have some pretty steep angles. Moving one away lowers it by just a little bit. But as we get to the sort of that 45-degree angle, moving one away here makes a big difference on the side of our barn. But as we get further, if we're out here, moving 1 unit away is not as big of a deal either. All right. Hopefully I didn't make a miscalculation in there. We'll see. But I hope once again that makes sense. that all of these things make sense with this picture, at least how to go about and do that process.